Let's focus on the unique local IPv6 unicast option that we have. So going back to unicast addressing, we have global, which is routable on the internet. We have link local, which is not routable at all. And then we have our unique local unicast addressing, which is routable inside of our organization. All right. So what is the address range we're dealing with here? It's a very specific prefix. You'll see here that it says FC00:7. So let's break that out right now into binary. We have FC00:7. So what that means is the first 7 bits are always going to be the same. So let's now see what our total range is. So what is F? What is F in binary? It's 1, 2, 3, 4. What is C in binary? Well, C, we have A, which is equal to 10, B, which is equal to 11, C is equal to 12. So we need 8, 9, 10, 11, 12, and that's what C is, 1, 1, 0, 0. And then we have 0, 0, 0, 0, followed by 0, 0, 0, 0. Now, I'm only concerned about the first 7 bits. So let's go ahead and say 1, 2, 3, 4, 5, 6, 7, and then the rest is our whatever we want them to be. So what this implies right here is that with those first 7 bits always being 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, the first 7 bits, then we only have a very specific range that we are dealing with. So if this here, the top address here, that is going to equal FC00. So that's our starting address. So if we have all zeros throughout our address, and we start off with FC00, and then everything else would be all zeros as an example. And then down here, the X's, of course, the maximum value of an X would be 1s, and the minimum value of any binary bit is 0. So zeros or 1s. Well, we already figured out what it's going to be if it's all zeros. If it's all zeros, it's just FC00000000. But what if all those X's are 1s? If all those X's are 1s, so the maximum possible value, so let's put a whole bunch of 1s in there, then the maximum possible value would be FC. And then what do we have here? Okay, so there's 1, 2, 3, 4. That's F. 1, 2, 3. Ooh, it's not C anymore. It's not C. What is that? That's D. That's D, because now the next 4 of them is 8 plus 4. That's 12 plus 1 is a grand total of 13, and 13 is D. Very nice. Very nice. All right. And then we could have all 1s throughout the rest of the address. So FDFF. Essentially, FFFFFF all the way to the end. So we go from FC000000 all the way to FDFFFFF. Okay, so that's the range for our unique local IPv6 unicast addressing, which are routable inside of our organization, but not routable on the internet. Now, notice here that there's this subnet prefix right here. These 41 bits that you can have as anything you want them to be. So the first 7 bits have to be from F. The first 7 bits have to be what we said. But after that, you can use any bits you want. After that, you can use any bits you want. So we can go in this range from here to here as the first 7, and then anything else you want after that in any combination possible. That's the 41 bits you see in here. That's going to be known as your /48 address. That's your /48 address. And then what you're going to do is you're going to subnet that /48 address into a whole bunch of /64s, which gives you 65,536/64 unique networks, all based on the same original /48 bits. So how do you come up with the addressing here? Well, you do whatever you want. Doesn't matter. But here is what they've tried to do in the real world. They've tried to come up with a way to make sure that we never, ever, ever, ever will have a conflict in the real world. What do I mean by never, ever, ever, ever have a conflict? Well, with our private IP addressing schemes for IPv4, which this is very similar to, when do we end up with a conflict with private IP addresses? For example, the 10 network. When do we end up with a conflict? When 2 companies merge together. This company's using the 10 network, this company's using the 10 network, merge them together, we have a problem. Well, we never want to have that problem with IPv6. Never. Right? There's so many addresses available. If we ever merge 2 IPv6 networks together, we don't want to have the same /48 prefix in both these networks. So the idea here is to go out on the internet. And there's many, 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 many IPv6 unique local address generators. That's right. Generators. Go to your favorite search engine and type in IPv6 unique local addressing generator. And what are you going to receive? You're going to receive various results, various web pages where you can go to and click generate. And every time you click generate, it's going to give you a new /48 prefix based on the first 7 bits being what we said right here. That's right. So then it's going to throw a value out too that starts either with FC or FD, because we can go in that range, and then randomly generate the rest of the bits for you. And the odds of some other company in the world that you could ever possibly merge with having the same /48 bits is next to none now. Is next to none. That's the idea behind this. So if you ever buy out a company using IPv6, you merge together, you're not going to have to readdress your network if you're using unique local addressing, ever. If you do end up merging with a company with the same /48 prefix, you just won the lottery. You might as well go out and buy a whole bunch of lotto tickets, because your odds of winning the lottery are better than having the same /48 prefix as another company during that merging process. So the idea here is to randomly generate your /48 bits within that the appropriate range of values here, and then go ahead and subnet down for your /64 addresses, so creating 65,536, and then you're going to have 2 to the power of 64 devices in each of those 65,536 networks that you just created.